Okay, this time I'm gonna be using three variables to see if there is a relationship between these three variables. So the first thing that I'm gonna do is to calculate the scatter plot, and then I will calculate the correlations with these variables. So I have my age, my height, and my weight, and I'm gonna assume that there's gonna be a relationship between these variables. So I will start by calculating to finding a chart for this, and here you have your three variables, and the first thing that I need to do is to select what kind of chart I want to be using. So I go to scatter plot, and then I'm going to select the basic scatter plot. Now, as you can see, once that I double click on that, then I get several options, and basically what I need to do is to basically drop the variables that I want on the different slots that I have. So I'm going to be dropping height here on the y-axis, and I'm going to put weight on the x-axis. That's really all you need to do. You can go a little bit more fancy by perhaps adding something like titles and things like that, but we're going to skip that for now. Okay, so once that you have your height and your weight, you just click on OK, and here we go. Here's your scattergram. Now, one other thing that you can do when you create charts in SPSS is to double click on the chart, and then what will happen is that you reactivate the chart, but this time you can actually go and do some fancy things with this. So say for example that I want to add a line that best fits. It seems like maybe a line that goes across in this direction will produce a best fit. So I'm going to click on this option here. You will see that it says add fit line, and then it just goes straight and adds this line. Now, I can have different types of options, like for example a linear or a quadratic or a cubic, but in this case I'm not going to be using any of those because it looks like my fit is pretty good. So there you go. Now I just close it, and then this chart goes back to the way that it was, and in this case it has added this line. You also notice that it added here something called R-square. R-square is the correlation to the square, and it's a measure of how well the fit is. In this case, um, um, we are basically saying that we are able to explain about 63% of the total variance. That's what this number 60.632 means here. Okay, so I said that I wanted to do that, and in addition to that I want to add some correlations. So now let's see if we can add some correlations. So in order to add my correlations, what I need to do now is go to Analyze, and here you will see that I have an option for Correlate. I can run a bivariate correlation, which is what I want, and once that you click on that option, you open a new set of menus, and what I will be doing in this case is that I want to add all my three variables here. So I will add age, height, and weight, and I'm going to be asking just for a Pearson correlation, but you can see that you have other options here. For example, we can also ask for a Spearman correlation. You can also ask for test of significance, so you will have a two-tail or a one-tail, and by default SPSS always flags the significant correlations. So we're just going to click on OK here and wait to see what happens. So after the program runs, it shows you this set of correlations. So this set of correlations will be the Pearson correlations. Um, and you can see that it creates a table that shows me the age versus age, age versus height, and age versus weight. And it tells me what is the strength of the correlation for the Pearson, 0.211 for the correlation between age and height, and 0.310 for the correlation between age and weight. So we have a correlation, but it's not significant. How do I know that? Because notice that it tells me here significance to tail, and I can see that for the significance for age versus height is 0.254, which is not significant, and for the correlation between weight and age is 0.09, which is approaching significance but is not significant yet. Now, how about for height and weight? You can see that here we have a very significant correlation, 0.795, and it has two stars. What that means, if you go and look here, is that the two stars means that the correlation is significant at the 0.001 level, two tails. So this is basically saying that the correlation between height and weight is significant, and is in fact very significant. Now, the table is symmetric, which basically means that here we have age versus height, and here we're going to have height versus age. So it's basically the same correlation. You can see 0.211, 0.211, the significance is 0.254, 0.254, and the number of scores is 31, 31. The same thing here. For example, we will have the weight versus height is 0.795, and it's the same as if I find the correlation of height versus weight. And now below, I also ask for the Spearman-Brown correlations, and so what I have next is this set of correlations. So now in this table is basically showing me now the set of correlations, the Spearman-Brown correlations between age, height, and weight. And you notice that the correlations are very close, but not identical to correlations that we had before. And that's because of the way that the correlations are calculated when you are using a non-parametric measure like a Spearman.